All right, gang, this is I guess what I would call the second constructed response from the 2019 bunch. And fun fact, I am almost positive that I have literally never tried this one before. Like I haven't really read this one through. I'm doing this basically, like I'm basically winging this one. Not that, I don't know. That's a little misleading, I guess. I mean, like it's not like I'm always copying off of a key. Um, I guess what I'm saying is I don't think I've ever done this one before. Like I've never even like read this through or thought about how this one should be done. So this will be interesting to kind of like see how my process, how I actually sort of do these as if I was sitting in the hot seat like you are, you know? Like if I was actually the one taking this test, what would be going on through my head? So here we go. Let's do this. This will be fun. 4 people each deliver food to people's homes. Interesting. That's a good start. 4 people each deliver food to people's homes. Curtis charges a flat fee of $2.50 for each delivery plus 20 cents per mile, or $0.20, basically 20 cents. $0.20 per mile for each mile he drives. For one delivery, Curtis drives 6 miles. How much does Curtis charge to deliver the food? Okay, here we go. I mean, obviously, this is the first time I'm ever seeing this particular example, but I've done stuff like this before, so I guess I can. Well, I mean, I guess that's why I'm the teacher, right? So, all they want to know is how much Curtis charges to deliver the food for 6 miles. Okay, so they must mean the entire. Okay, so they must mean like in total. So a flat fee of $2.50, just no matter what, for every delivery, plus 20 cents per mile. And Curtis is this is simple. Curtis is driving 6 miles, and they want to know how much Curtis charges to deliver the food in total. Now, you don't actually need to write down a full equation to model this, but I don't know. So let's say like the total, we'll call T, is going to be 250 plus 0.20 times M, where M is the number of miles. So M is the varying, that's why it's a variable. This is like whatever the number of miles is, and T is going to be, the total charge. Now here, they give us 6 for miles. So again, you didn't actually need to write it all out exactly like this, but we're going to basically plug in 6 for M, and we're going to, again, I guess the bottom line is that you're going to have to multiply 6 times 0.20 and then just add on the 250 like this equation is saying. So let me go to I don't think I need a calculator here, but let's just make sure. So 0.20 times 6 which is $1.20, and then we're going to add 250 and end up with I'll even throw in the so $3.70. Okay, $3.70. Yeah. For a second there, I was thinking about how you could have made this problem a little more convoluted by also tossing in like, okay, I'm sure he also charges for food, the actual food costs money, but it looks like $3.70 on top of that for the delivery. But this is all the question wanted. How much does Curtis charge to deliver the food? $3.70. Audrey charges a flat fee of $4 for each delivery plus a certain amount. A certain amount. I immediately want to say, okay, so that's going to be some kind of variable in dollars per mile for each mile she drives. Audrey's a little more expensive, huh? For a distance of 30 miles, Curtis and Audrey charge the same amount. How much does Audrey charge in dollars per mile? Show or explain all your work. Well, I don't like explaining my work in writing, so I'm just going to show all my work. So what do we do here? I mean, I have a plan. I wonder what your plan would be. I'm basically going to first figure out, what Curtis is going to charge for 30 miles. So we know that Curtis would do, and again, if I'm going to show all my work, then I might actually need to show all of that, where I actually write down, the 2.50 plus, 0.20 times 30, and like showing every step. And I mean like actually showing that 30 times 0.20 is going to be, I believe, $6. But let's just check my calculator. Again, do not ever assume that your mental math so that gets me 6. So Curtis would charge $8.50 to go 30 miles. That means that Audrey charges the same amount. See, again, for a distance of 30 miles, Curtis and Audrey charge the same amount. So Audrey, right, is also going to be so $30, but for Audrey, it's now $4 every time, plus some unknown per mile charge times 30 miles. So here X is the unknown per mile charge. See, for Curtis it was 20 cents, but for Audrey we don't know it, so we're calling it X here, for now. Okay, so 30 miles times something. So now I can take this equation, and oh my gosh, I'm an idiot. I am an absolute moron. Good thing I caught that. Total charge for 30 miles is $8.50. Whoa. So now I'm going to solve this equation, okay? Yeah, total charge for 30 miles, Audra's classing. Okay, jeez. So here I'm going, and again, if I'm going to show all my work, I'm going to write down every little thing. Because again, when they say show or explain all your work, they want you to be very, very thorough. Whoa. What could this be? 4.5 divided by 30 on my calculator. I am getting $0.15. Oops, sorry about that. Dividing both sides by 30. My calculator tells me that 4.5 or 4.50 divided by 30 is that. So that's 15. Oh my God, sorry, my paper moved there. So that's 15 cents or $0.15. And so that is my final answer that I'm going to go with. $0.15 is what Audrey, so let's just make sure that's what they were asking. How much does Audrey charge in dollars per mile? Yeah, that's it. Part C. Let's see what surprises we have in store here. The amounts of money Peter and Maria each charged to deliver food are described below. Okay. Peter charges a flat fee of $3.75 for each delivery plus 10. Okay, so it's following the same sort of deal as Audrey and who? Curtis? They're talking about a flat fee. They're also talking like a per mile charge. Maria charges. Okay. Peter says there are two. Obviously, these numbers are going to be very important in a second, I'm assuming. Peter says there are two distances for which he and Maria charge the same amount. That doesn't make sense. To prove Peter is not correct, Maria graphs a line for her delivery charges and a line for Peter's delivery charges. Each line represents the relationship between the amount Y in dollars each person charges and the distance X in miles each delivery. Without showing the graph, explain how Maria's graph of the two lines proves Peter is not correct. All right. Well, where should I begin here? I'm obviously inclined right here to give a pretty thorough explanation of this whole deal, but then also write out a pretty good answer that I'm sure would get full points from whoever would be grading this. Okay, so first of all, it is pretty much necessary. I'm going to go with, I'm going to actually say, it might be necessary to actually write out this equation, at least for my purposes of explaining this right now. So Peter's equation would be 0.10x plus 3.75. If x is number of miles and y is the total amount of dollars, that would be an equation that fits Peter's whole deal. 3.75 or $3.75 no matter what, and then 10 cents per mile, so you do like the 0.10 times the number of miles. For Maria, it would be 0.25x plus 2.25. Now, if the question, here's what I'll say. If the question was just asking, hey, for what number of miles would Peter and Maria charge the same amount? If that was which is a very common question. So, let's say the Keystones asked you that, hey, what is the number of miles that Peter and Maria would charge the same amount? You could answer that question a number of different ways, You are essentially solving a system of two equations at this point in time. It's a system. And you could basically just start guessing and checking. How about 1 mile? And plug it into both of these. How about 2 miles? How about 3 miles? How about 4 miles? And just keep guessing and checking, Now, that is not the best way because, what if it actually turns out to be, 1.5 miles or 1.9 miles or 5.12, you know what I mean? If the final answer is really nasty, like decimal-wise, just guessing and checking is not the way to go. So solving a system, you could actually go ahead and do like the substitution method, which involves just setting these two equations equal to each other, like 0.10x plus 3.75 equals 0.25x plus 2.25, and then like solve for x. Like you could, but the bottom line here is you're only going to get one answer for X and then in turn for Y. You're only going to get one combination of X and Y that solves this system. Maria is talking about how, let's see, to prove Peter is not correct, Maria graphs a line, both of them. She graphs both of these lines, and each line represents, all the solutions, right? Because again, I guess I'll be thorough here. Because again, if you graphed this line, it would contain all of the solutions for Peter, all the different relationships for Peter charging, and then this line would contain all the different relationships for what Maria charges. And where these lines cross, so now I'm really getting to the point here, okay? I'm finally getting to the point, no pun intended. Where these lines cross are going to be, where Peter and Maria have an actual combination in common, okay? So without showing the graph, explain how Maria's graph of the two lines proves that Peter's not correct. Okay. I don't know how thorough they would expect this to be and how detailed, but I would point out that without showing the graph, what would be the bare minimum of an explanation here? Since I almost want to write a first draft here first, but since the slopes of the two above equations are not equal or not the same, the two lines will only intersect in one spot, or they will only have one point in common. See, again, I don't know what the best explanation here is, but the bottom line is these two lines are only going to intersect. They're going to have one point of intersection. Will only intersect in one spot. Therefore, Peter and Maria will only have Peter says there are two. Will only have one distance that is, equal. This is so weird to say. At the same time, the total charges are equal. So again, it's I don't know, something like that, where you talk about how the two lines are only going to intersect in one spot, which means they're only going to, Maria and Peter will only have one combination. That's a good word to use, combination. They'll only have one combination of miles and total charge in common. That's a really good way to say it, actually. Because each line contains all of their individual combinations. Peter's line contains all of his separate combinations, and Maria's line, all of her individual combinations. And if these two lines are only going to intersect at one spot, because that's how lines are, then Peter's wrong and Maria's right. Okay?